Okay, YouTube, here we have some colorless gems, right? Diamond simulants. We're going to be using thermal probe to measure the conductivity, okay? So here we go. Synthetic moissanite. Very quickly goes up on the chart. The next stone is natural topaz, okay? Slowly goes up. All right. The next stone that we have is yttrium aluminium garnet. Very similar thermal conductivity properties of natural topaz. Okay, very similar. These often get confused with one another in the marketplace, right? YAG is pretty uncommon in the marketplace today. This was before cubic zirconia. This came out in the late 60s, early 70s. Okay, so here we have cubic zirconia. And on this instrument, nothing happens. So we can keep it on there and nothing happens, okay? So here is a calibration, right? So this is sapphire. You guys can see that it stabilizes right in the middle, okay? So it right in that black. And this is diamond, and it's a similar thermal properties, and it goes up very quickly, right? So here's, diamond simulants. See this? Synthetic moissanite, very quickly, goes up. And cubic zirconia right here doesn't do anything, right? Because it's a very poor thermal conductor. So this instrument, if we can look here, it has 80 watts per meter Kelvin is the threshold. So right here is about 40, and this is an inch or 3/4 of an inch. This is about, the T is like 20 watts per meter Kelvin. So this instrument is just like those Presidium gem testers that has those, lines of, gemstones that it can be or cannot be. If you understand, the thermal conductivity properties of, semi-precious synthetic material, you eliminate spending $300 or $400 when you can get, this is the first model diamond tester. This is the very first one that's patented. So even the Gemological Institute of America made a tester similar to this one, and it was called the Gem Diamond Tester. So they have these analog meters, and if you understand, the limits of these machines, you have a great understanding of thermal conductivity properties of gem materials. You can use these to make your first line of defense. Now, all of these synthetic stones are off the limit of a standard refractometer, except for this white topaz. This white topaz has a very low refractive index of about 1.61, and we can make the call on its refractive indices. But these other stones, we really can't make an accurate refractive index reading, but we can determine that these stones have high refractive index because this stone has no read-through effect, and these stones have, this one has a great deal, cubic zirconia has a great deal of higher refractive index than YAG. This YAG, there's a reason why CZ replaced this material. This has higher refractive index and higher amounts of dispersion, right? So this is the reason why CZ is so popular today as a diamond simulant, because it has very similar properties. So I hope you guys enjoyed this video and have a great day.